we're going to talk about a very important topic in post-harvest handling, and that is about maturity indices. Basically, maturity indices are the criteria that we use to decide when to harvest. But more importantly, it's the criteria that we use to decide when to harvest for good eating quality and good shelf life, trying to strike the appropriate balance there between those two. Maturity indices are important for various reasons. They are the harvest indices, as we already just said. They are related to sensory and nutritional quality, and I'll show some examples of that. And also, the maturity indices do differ if it's for fresh market or for processed. Think of tomatoes. We may harvest tomatoes at various stages for fresh market, but for the processing market, they would be strictly red tomatoes that are harvested. No? Maturity indices may help us achieve adequate shelf life, as we already mentioned. And also they're related with marketing. In other words, we do have some standards that include maturity indices, and we'll mention a few of those. And then think of maturity indices that also affect the yield at harvest and the culinary use. For example, lettuces can be harvested at various stages, but we would have little yield if we harvest them too young at harvest. And also a chef would have less yield of salads in the restaurant. So we are concerned about that overall aspect of productivity and maturity indices. Now, this is a very nice example of what we call the development of fruits. So all of our products, really, we're harvesting at some stage. Think of in the area of cell division here, we're looking at tomatoes in this case, but cell division could be sprouts that are recently developed. In cell expansion could be some of our vegetables that are very rapidly growing, things like asparagus or the broccoli or products like that. Then we have other products that we're harvesting when they're nearing maturity or they have reached maturity, and that could be in the fruits, something like a tomato that is capable of ripening once it reaches the mature stage. Or think of potatoes that would be stored. Then we're concerned about harvesting them when they are mature. Then for our fruits then, when we harvest them mature, they go through a ripening phase. And then finally, all of our products will go through that senescence or that phase of deterioration, which is, of course, is what we're trying to prevent in post-harvest. So this photo very elegantly shows those different stages of development that are related then to maturity indices for different products. Now, maturity indices really are an indication of when we harvest at a particular stage of development. So as I just mentioned, different products are going to be harvested at different stages on that developmental continuum. No? Products that are harvested early in development, again, are many of our vegetables, and they can be roots, leaves, stems, etc. Products that are harvested at the mature and ripening stages are almost always fruits, meaning they develop from a flower. And an exception I already mentioned would be potatoes that we would harvest at the mature stage, or onions that would be stored we would harvest at the mature stage. But when we think of maturity and ripening in particular, we're thinking about fruits in our in post-harvest handling. So there are some terms that are important to know and to distinguish. One is the term physiological maturity. So that is specifically applied to fruits. When can a fruit be harvested and continue its development, meaning its ripening? So for many fruits, there are criteria to ensure that good shelf life and good eating quality, and that's enabled them to reach the consumer then, so they are able to ripen and have good quality. And in the fruits, we can talk about fruits that are immature, they're not ready to harvest. We can talk about fruits that are mature, they could be harvested, but that oftentimes might be for distant markets, so we're trying to lengthen the overall post-harvest period. Then many fruits are harvested at some stage of ripening, so they've transitioned from the mature into the early ripening stage. And an example would be melons, for example. So that's probably the best stage. We want them to begin that ripening process, and that's when we would harvest them. And then for very local markets, we may be interested in harvesting the fruit ripe, a near red tomato, to be able to harvest it locally, for example. And of course, then we have fruit that are overripe, and I put on there, well, useful for jam, right? So they could be overripe even for, fresh consumption, okay? So physiological maturity, again, is applied to fruits. Then for many of our vegetables, we use the term horticultural maturity. because this implies that we're going to harvest it according to when the buyers or the consumers want the product, the size or the characteristics that they want. So here we use some of the same terminology. We use the term immature, meaning that for that market it was still too young, it was too small, okay? And we have the term mature, and that may be then the desirable stage that we want to harvest. And also for those products that we're going to be storing, like onions or potatoes, that would be an important stage of development to ensure that they can be stored better. And then also some of our vegetables we harvest over mature. Think about, say, celery that's too tough. Any of those vegetables, or asparagus that again is too tough. So it is possible for us to harvest then those vegetables over mature. So you can see here that we're using some of the same terms, but they have different meanings depending if we're talking about vegetables or fruits in a way. So distinguish between that horticultural maturity and physiological maturity. Now let's look at some specific examples. So here we have examples where basically our harvest indices or our maturity indices are based on size plus some other characteristic. There's asparagus, for example, so it's the size of the spear of asparagus, but it's also related to the apex or the growing point must be closed. So those tips of the asparagus should be closed. If they're opening, that means that asparagus will be over mature. Something like broccoli, then on the lower right hand side we have immature, mature, and over mature. And so again, the broccoli is based on size of the head as it develops, but also those individual little florets, which eventually will become flowers, go from an immature to a mature to an over mature stage for a fresh market. And so we have to look at those and also then distinguish. So again, size is important, but there's that other characteristic. Now carrots is really based on size. We can harvest them very early in development, or we can harvest them more mature, and that's really based on size. Something like lettuce, again, is size, but it's also based on the firmness or how solid the lettuce head is. And here, for example, I have an iceberg, head of iceberg lettuce. And this one I picked up because exactly, if I were going to buy this, I would say, well, that's a good maturity because I picked it up, it had a plastic wrap on it. I picked it up and I could squeeze it slightly. And so then when you cut that iceberg lettuce, you see that internally we have some structure there, but we still have a lot of green tissue, and that is a very nice head of lettuce based on its maturity. So we would say that is mature, but not over mature, not too solid, and that will have good eating quality. Okay, so here it's really the definition or related with these is that we're really harvesting these vegetables when the buyer or the consumer wants us to harvest them, okay? Now, as we move into other vegetables, something like a potato can be harvested at many stages. So here we have different stages of development on the plant, and you can see that we can move from very small potatoes. We can move from very small potatoes that's shown in that photo on the left on the top, but those are going to be very young and tender, and the skins are not fully developed. So we get a lot of scuffing and a lot of damage to those potatoes, but they have a very particular flavor because they contain more sugars. You can see that they might have somewhere around between 3 and 5% sugars if we harvest them very young. And then as the potatoes mature, they're going to have more starch and very little sugar. And those would be the potatoes that are mature, and they would be used for storage. But essentially for potatoes, depending on what the market wants, we can harvest them at different stages. It's just important to know specifically then what the buyer or the consumer wants in terms of the maturity of that potato. Now here's an example now of immature fruit vegetables. So these came from flowers, but we harvest them at very early stages of development. And there's a graph there, and you can see that first of all, after the flowering, there's very little change in size, and then all of a sudden over a few days we have a very rapid expansion of the size, and then it reaches a mature stage, which is really over mature from the standpoint of when we want to harvest them. And there you can see some of those zucchini squash. The top three are acceptable depending on the market, and then the bottom one obviously is completely over mature and it wouldn't be acceptable for any fresh produce market. The point here about many of these vegetables is, although we're harvesting them based on size that we can see, they change very rapidly on the plant. So on a hot day, they grow very rapidly. So sometimes we have difficulty getting in to harvest them exactly when we need to harvest them, and they just get away from us. The fields get away from us, and we have too many over-mature fruit. And in that case, we have to just cut off the over-mature fruit to allow then the younger, higher quality, immature vegetables then develop. And you can see this applies to green beans, to cucumbers, to okra. They all have this similar type of growth curve. Now we're moving into the mature fruit vegetables, and so these then are from fruits, and for us to have good storage, they have to be harvested when they've reached then their mature stage. Here we have an example of peppers, for example. Peppers can be harvested when they're green, so that's a green, mature green pepper. Or if we're harvesting colored peppers, red or yellow, then we would harvest them somewhere in between that. We wouldn't harvest them when they're completely colored because we would lose shelf life. So we'd harvest them at that chocolate stage, as in the middle you can see there, or with some combination of the final color and some greenness. No? We'll talk about tomatoes in a moment, but let's look here on the squash. Here we have a couple clear indicators of the maturity of these winter squash, this kabocha. You can see that the outer skin has differences in color. So as they mature, they lose that bright green, dark green, and they become more of a dusty green or a gray green, if you will. And then also you can see that the stem end has more corkiness as it matures. And that's a very important aspect to achieve good storage of this type of vegetable. And then if we cut those, you can see also internally they have a very different appearance, and that's related with the carotenoids. So the more mature that winter squash, the more carotenoids it's going to have, and better eating quality and better nutritional quality. All right, now let's talk about tomatoes. We can harvest tomatoes at various stages. Here in the United States, we market tomatoes with using basically the USDA color chart, and so they have 1 of 6 stages. No? So a tomato that's in stage 1, we say it's green. We say it's mature green. And based on our definitions, what that means is if we harvest it at mature green stage, it is capable of continuing the ripening process. In practice, though, we often give it a treatment with ethylene in order to make that process more uniform. Now, the stage 2 through stage 6 are all vine-ripe tomatoes, because there, the definition vine-ripe means that it has begun to show some color on exterior color when at the time of harvest. So here, number 2 is a vine ripe. It's not table ripe. Table ripe would be stage 6. It's full red and now it's ready to eat. But a vine ripe tomato is anywhere from stage 2 through stage 6. If we're marketing locally, we would want to harvest maybe a stage 5 or almost a 6. But we usually do not want to harvest full stage 6 because we don't know exactly when it reached that full red color. So typically we're harvesting just slightly backing off from that full red stage for a local market. Then if we need to store them for a period of time, a couple weeks or so, we might harvest in the stage of, say, a 3 or 4 to gain that shelf life without compromising eating quality. Those will still be very good eating tomatoes to be harvested at stage 3 or 4. Okay. Now, moving on. That being said, for our round tomatoes, our large tomatoes, when we are dealing with small tomatoes, we want to make sure that we don't harvest them earlier than about a stage 4. And here's a chart showing the composition of these tomatoes if we harvest them at 3 stages. And I have just outlined in red the aspects of soluble salts and titratable acidity. So here we have those 3 maturity stages, or really they're stages of ripeness actually. So we're talking about that ripening phase. So instead of maturity stage, we really technically should say ripening stages, correct? And now you can see that the soluble solids that the fruit will have when they reach full red color is very different. It goes from 5.9 if we harvest them at a ripening stage 3, all the way up to 7.5 soluble solids if they're harvested at stage 5. Then you can look at the titratable acidity and see that also that changes depending on the stage of ripeness at harvest. So for all of the very small tomatoes, we want to harvest them at least at a color stage 4 in order to have a good eating quality. Now, the tomatoes is a good example of what we call group 1 fruits, or I'm calling group 1 fruits. And the basic distinction, we're going to have 2 groups, okay? So group 1 are the fruits that do not contain starch. And that is important because that means they do not get sweeter after harvest. And that's why the maturity or the maturity and the ripening indices at time of harvest becomes so important. You can see that this is a large groups of fruit. It includes actually most of our fruits. So that's why we emphasize maturity indices in these fruits. And you can read through the list and you know that some of these are of concern. We tend to harvest them too soon for good eating quality. So remember, group 1 fruits do not have starch that then in the post-harvest period would form the sugars. And so therefore, whatever sugar, whatever soluble solids or sugar content we have at the time of harvest is the maximum we're going to have during the post-harvest period. All right, now a couple good examples. Now, one is cherries, and here we have an example. I have an example of cherries. Here you can see this clamshell of cherries, and you can see the variation in color. And this is fairly typical. And again, another example of another clamshell here in the photo, and you can see we have dark ones and red ones. So what's the importance of this? It is that the color is directly related to the sugar content. So as these cherries mature and then begin to ripen and show color change, the cherries with less dark color, less red color, like this one here or this one here, they're going to have less sugar. So there's a direct relationship between that color development and sugar development in the last few days before harvest. So we say for cherries that color is a very good indicator then of the sugar content, and we want obviously then to harvest the cherries as an advanced stage of ripeness as possible, because that will ensure the best eating quality. Okay, so you can see here in this box I say how is the maturity or stage of ripeness in this commercial box, okay? And so a little bit deficient, right, but that's quite common. Related fruits, these do not contain starch, so we're concerned about meeting a standard of maturity that allows for good eating quality. And you can see here for the stone fruits, there are some specific, a lot of it's based on what we call the ground color, also internal color changes with time. And so some of the stone fruits can be fairly complicated in terms of deciding when to harvest them. But really, if you're working with stone fruits, you want to know very well when to harvest the particular variety that you're working with in order to have good eating quality. Here's another example. Again, here's a fruit. The sugar at harvest is what we have, and you can see these strawberries could be harvested at different stages of color, 25, 50, 75, or 100% color. And right there you can see the difference between the soluble solids and the acidity, and of course that's going to affect the flavor of the strawberries in the end, the consumer acceptance. Here's an example of cantaloupe melons. Here we have various indices, but basically what we commonly use for our western cantaloupes is when that stem begins to separate from the fruit. And here you can see in that photo a figure pulling away the stem. So it's beginning that separation process, and that is when we know that the melon is beginning the ripening process, and that's when it will have a good content of sugar. The graph on the upper right hand side, you can see there's two lines. The green line shows a melon, the actual sugar content of a melon at the time of harvest. If we harvested it by cutting it, and we did not harvest it when that abscission zone was forming. Then the orange line shows when the melon was harvested and the abscission zone was forming. And what you can see then with time after harvest is there's always a difference in the sugar content of those melons. The one that started with the most sugar always will have more sugar, but you can see that also the sugar content declines after harvest. And so that's why we say the maximum sugar we will have in group 1 fruits is at the time of harvest. It's always going to decline during the post-harvest period. Another example, and I find these particularly difficult, are determining the maturity or the ripeness of watermelons. Again, these are fruits that the maximum sugar is going to be at the time of harvest. And a fairly recent paper emphasized the use of the dried tendril. So that small tendril, and in the case of cantaloupes, it's a subtending leaf, that those are very good criteria to harvest the watermelon. And so you can see here in the example we have fruit that will be on the immature side, the mature and the over-mature. You can see internally, visually, they look quite different, as well as there will be differences in soluble solids content. So more examples of this group 1 fruits that are very important would be grapes. And here we have specific standards that emphasize a minimum soluble solids and or a soluble solids to titratable acidity ratio. In navel oranges, we have what's called a California standard. This is a fairly recent development because we have had trouble with maturity standards with the navel oranges. And here, this standard pays more attention to the acidity of the fruit. So early in that ripening process, we have more acids to the sugars, And so this California standard takes into account the acidity. We're measuring the same thing though to get at the standard. We measure the soluble solids and we measure the titratable acidity. It's just that the calculation is a little bit different. And then for something like lemons, we go on the basis of juice, because as that fruit develops and matures, then it's going to get more, the juice is going to get juicier in those in the juice fats of the fruit. Something like a pomegranate, we go on the basis of acidity. The acidity has to be below a certain amount, or part of the standard could be the juice color has to reach a certain number on a color chart. So those are just a few other examples of the group 1 fruits. And again, I want to emphasize that these group 1 fruits have maximum sweetness, maximum sugar content at the time of harvest, and that will decline after harvest. So there are taste changes after harvest, but these fruits are not capable of getting sweeter based on sugar content. Okay, so then we can distinguish between the group 1 fruits and the group 2. These are fruits that do contain starch. These are fruits, group 2 fruits are those that do contain starch, and the importance of that is then the starch is converted into sugar during the ripening process. We have some very important fruits in this category. We have apples, we have bananas, and everyone knows that bananas go from a very starchy taste to a very sweet taste during that ripening process. But you can see the number of fruits is fairly limited. So we want to be very clear that most of our fruits really are in that group 1 category. But here we have some important fruits, our pears, our apples, our bananas. So some of those fruits that we store for long periods of time, kiwis, for example, also, then they do have starch that's converted to sugar. And in this case, there are some specific harvest indices, maturity indices. For example, for apples, it's common to use an iodine test. And we have an example here of the test for Granny Smith. And so the minimum standard is between a 2 and a 3, but typically they would be harvested between stage 3 and 4 for better eating quality. So this is specific to a cultivar of apple. For pears, specific to a variety would be the firmness, and that's a very common criteria to decide when to harvest. So each of the fruits may have a little bit different criteria, but again, the idea there is striking that balance between the final eating quality and the storage life that some of those fruits need to have. Now here's some Golden Delicious at a retail market, and I just circled those. As a consumer, which ones am I going to buy? Well, I'm not going to buy the ones circled in green, right? Because those look very green, they were harvested very green, and even with time, even though those fruits have starch, they're not going to have the same eating quality that the fruit that were harvested at a better maturity or ripeness stage have, and those I've circled in red. So the ones circled in red are the ones that I ended up buying, right, because they're going to be better eating. All right. So maturity indices, really, we're talking about a balancing act. So again, we want to achieve a good eating quality, but we also need to achieve the needed shelf life. So if we harvest the fruits, in particular, at lower maturity, many times they will not ripen. I put never ripen here, but they will ripen very poorly. Often they will shrivel because it takes so long to ripen. They will have poor flavor, and that means consumers won't go back and buy the fruit again. Yeah? And they may have long shelf life, but in a way, who cares, because they're not going to be good eating quality. So if we harvest with very high maturity, sometimes we'll see that we will have more decay. The fruit will have better flavor. They may be too soft, so we have to strike again a balance there. The fruit will be more prone to injuries, so when we harvest the fruits that have higher maturity, then we have to handle them more gently. And then these fruits may have poor shelf life, so there's a balance there. So we're constantly trying to balance there on our different fruits in particular about when we should harvest. So the thing to remember about maturity is that we need to make sure that we know exactly the stage of maturity or the stage of ripeness that we want to harvest our products, whether it's a vegetable or whether it's a fruit, and in the end it's to meet consumer expectations and the needed shelf life. So thank you for your attention.